Hello friends, welcome to our video session for amplitude modulation. For those who are visiting to this channel for the first time or who haven't watched first video about modulation and demodulation, please watch that video so that you will be aware about the terms which we have discussed in the first video, which was about modulation and demodulation. So I'm going to continue assuming that you have watched that video. Now we'll discuss about the amplitude modulation. Amplitude modulation is a modulation in which the amplitude of a carrier wave is varied in accordance with same characteristics of the modulating signal. Like we have information signal and carrier signal in the given figure. These signals are imposed to each other. The information signal and the carrier signal are imposed to each other to get amplitude modulated signal shown at the bottom of the image. In the figure you can see that the amplitude of the signal is not same. It is varying according to the message signal, and this have amplitude modulation. Sorry, this is how the amplitude modulation is done. We will discuss some important formulas. First is sinusoidal carrier wave, which is CT equal to A cos omega CT, where A is the maximum amplitude, omega C is the carrier frequency. And the next equation is for standard equation for next equation is standard equation for amplitude modulation, which is ST equal to A plus x of t in square bracket cos omega CT. In this equation, A plus x of t is also known as the envelope, and it is denoted by ET. Thus ET equal to A plus x of t and is called as envelope of amplitude modulation. An important point to note in amplitude modulation is that the frequency and the phase of the signal remains same, and they are not changed. Only the amplitude varies according to the message signal, like we have already seen in the previous slide. This equation, which is standard equation for amplitude modulation, is very important from the examination of point of view. Sometimes there may be a numerical on this equation. Now we have an amplitude modulation spectrum and its bandwidth. Here the image shown is a graph for the amplitude modulated signal. You can see in the image that an amplitude modulated signal consists of a carrier wave with two sidebands, and these sidebands are the upper sideband and the lower sideband. Lower sideband is on the left side and upper sideband is on right side. It is clear from the image shown here. And here an important formula arises, which is about calculating bandwidth, calculating signal bandwidth, and is defined as signal bandwidth is equal to 2 into audio bandwidth. Here the audio bandwidth is our signal, you can say it is a baseband signal. It is clear from the graph that the frequency range of upper sideband and lower sideband is equal to frequency carrier signal, and which is again equals to the 2 times the frequency of the modulated signal. You can see here that the frequency of the carrier signal is 2 times the frequency of modulated signal. Next, we have modulation index. Modulation index is also known as amplitude sensitivity, and it is also known as degree of modulation. The third name is depth of modulation, and fourth name of the modulation index is modulation factor. Now the modulation index is defined as it is how much the modulated variable of the carrier signal varies around its unmodulated signal, and is represented as the ratio of highest value of modulated amplitude to the carrier amplitude. You can see here h is the modulation index, and it is expressed as m over a, where m is the modulation in amplitude and the a is carrier, sorry, where m is modulation amplitude and a is the carrier amplitude. And an important point to note here is that the modulation index is always expressed in percentage, and questions will be asked in the form of percentage. Now we will discuss about some important formulas on which questions may be asked in the exams. First, we have expression for single tone amplitude modulation, and it is expressed as st equal to a cos omega t, and square bracket start 1 plus ma cos omega m t square bracket close. Here a is the amplitude of modulated signal, ma is the modulation index, omega c is the frequency of carrier wave, omega m is the frequency of modulated signal, and ma is the modulation index which we have calculated in previous slide, which is h equal to m over a. Next expression is for power carried by the upper and lower sideband, which is you can also say that the power carried by upper sideband and the power carried by lower sideband are equal, and is expressed as PS, which is power carried by the lower sideband, and PS USB is the power carried by upper sideband, which is equal to PS over 2, where PS is the signal power. Next term is total power of the signal, total power of the single tone and amplitude modulated signal, which is PT equal to PC plus PS, where PT is the total modulated power, PC is the carrier power, and PS is the signal power. These three expressions are very important for the examination point of view, and now the next expression is for total modulation index for multiple tone modulation and which is in our next slide. Yeah, here it is. It is total or net modulation index for multiple tone modulation, and it is expressed as mt equal to root of m1 square plus m2 square plus m3 square and so up to mn square, where mt is the total modulation index for multiple tone modulation, and the terms m1 m2 m3 and so on up to mn are the modulation indexes for different modulated signal. This is also an important expression from the examinations point of view. Questions can be raised on this too. With this, we came to the end of the topic. We'll catch you with next video. Thanks for watching.